So good afternoon to one and all. I am R.V. Kiran, Assistant Professor, Department of Mechanical Engineering, Chevron Engineering College. Today in this lecture, I am going to explain you about the Davis steering gear mechanism. So in the last part of the lecture 15, I have explained about the Ackermann's steering gear mechanism. And this is my 15th lecture regarding to the subject kinematics of machinery. So we have already studied about the Ackermann's steering gear mechanism in the last part. This is my second part regarding to the lecture 15. And coming to the second one, that is Davis steering gear mechanism. So this Davis steering gear has a sliding pair in which it has more friction to it than the turning pair. So when we compare it to the sliding pair, it has more friction than the sliding pair. So these Davis steering gear mechanism consists of a sliding pair because it has more friction than the turning pair. Therefore, the Davis steering gear wear out earlier and becomes inaccurate after certain time. So when they are using this sliding pair, it is going to be wear out in high conditions. That is when you are using it in high fractions. So మనకి ఎప్పుడైతే స్లైడింగ్ పేర్ లో ఫ్రిక్షన్ ఎక్కువ ఉంటుందమ్మా, మనకి స్లైడింగ్ ఫ్రిక్షన్ ఎక్కువ ఉందంటే ఏమవుతుంది, మనకి ఈ మెటల్ అనేది కానీ లేకపోతే మెటీరియల్ ఏదైతే తొందరగా అరిగిపోతుంది అంటే వేర్ అవుట్ అనమాట. సో ఇట్ ఈస్ గోయింగ్ టు బి వేర్ అవుట్ ఎర్లియర్ అండ్ బికమ్స్ ఇన్యాక్యురేట్ ఆఫ్టర్ సర్టెన్ టైం. సో ఎప్పుడైతే మనకి ఈ మెటీరియల్ అనేది వేర్ అవుట్ అయిపోతుందో మనకి కండిషన్స్ లో మొత్తంలో కూడా మనకి inaccurate గా తయారైపోతుంది అనమాట. సో దే ఆర్ గోయింగ్ టు బి inaccurate. This type is mathematically accurate. So this type of inaccuracy is mathematically accurate in position. And coming to the Davis steering gear, this is an exact steering gear mechanism, and this mechanism fulfills the above steering gear condition, but due to presence of these sliding members, the wear will be increased and this eliminates the accuracy. So in this condition, in this Davis steering gear condition, we are using more number of sliding pairs. So that becomes the inaccuracy position of the sliding gears. And in this Davis steering gear mechanism, due to the presence of more sliding members, the wear will be increased and this eliminates the accuracy of the steering gear mechanism. So this eliminates the accuracy of the steering gear mechanism. But when it is to be used, this is an exact steering gear mechanism. So when we are using the sliding pairs, it has more friction. So more friction means more number of work. So that is why it is going to be wear out early. So this is the Davis steering gear mechanism in which the automobile is turning to its left position. It is taking a left turn here. So this is the point of section B, and this is the second point of section of the same wheel with the D position. And this is the point of section A, and this is the second point of section C. So it consists of 2 points, and the displacement between the actual straight line and the displaced straight line is taken as small d. The thickness of the tile is taken as small x, and the angle between the two lengths is taken as two position of the wheels is taken as theta and alpha, and the position of the displaced wheels can be taken as phi. And you can see the instantaneous center here, and from this instantaneous center we are taking these centers as A and B. So from the right side wheel it is taken as A, from the left side wheel it is taken as B positions, and the angle between these two positions is indicated as phi and theta. So theta and phi is the two positions, two angular positions from the instantaneous center. And the length of between the axle is taken as C, and the length between two axles is taken as small b. It is taken as small b. The back axle length is C. Coming to the front axle, it is also same in position, which are parallel to each other. And by taking the triangles, it forms two types of triangles. From the left side of the wheel, that is the inner wheel, it is formed as IPB. So IBP is the first triangle, and second one is the IAP. So IAP is the second triangle from the right side tile. Next, it consists of a crosslink CD, which is sliding parallel to another link AB and is connected to the stub axis. So this is the sliding pair CD, which is the original position is AB, and this is the sliding pair CD. And this is connected to the stub axles of the two front wheels by means of two similar bell crank levers, that is LAC and MBD. So LAC and MBD is the two triangles formed from these sections, which is pivoted at A and B positions respectively, which is positions at A and D positions respectively. And the crosslink CD slides in the bearing and carries pairs at its ends C and D. So the crosslink CD is sliding at the positions of the positions bearing and carries the pairs at its ends C and D. The slide blocks are pivoted on the springs and moves with the turning of bell crank levers as the steering wheel is operated. So generally the steering wheel is operated in the side blocks of the conditions where it is connected to the pins directly. When the wheel is running straight, the gear is said to be in its mid position. So generally, when the automobile is running in the straight position, they are going to be set in the mid position only. And The short arms AC and BD are inclined at an angle 90 degrees plus alpha to their stub axils. So these are going to be defined at the stub axils AL and BM respectively. So they are 90 degrees plus alpha angles, and the correct steering depends upon the suitable selection of cross arm angle, that is alpha, and it is given by tan alpha is equal to C by 2B. So this position of the arms is taken as tan alpha is equal to C by 2B. So this is the value for the correct position of angle of the steering gear mechanism, that is tan alpha is equal to C by 2B, where C is equal to distance between the pivots of front axles and B is equal to wheelbase. So C is taken as the front axle distance. So the distance between the two axle positions is taken as C, and the distance between the two axles is taken as B. That is called as wheelbase. It is taken as C by 2B. The range of C by D is 0.4 to 0.5. Hence, alpha lies between 11.3 degrees and 14.1 degrees. So the range of C by B is 0.4 to 0.5, and hence alpha lies between the 11.3 degrees and 14.1 degrees. So this is the general angle position of the alpha. So this is the general angle position. So this position is 11.3 to 14.1. So 11.3 to 14.1 is the angle distance covered. Let A is the vertical distance between AB and CD. So let small a be the vertical distance between AB and CD, and small b is the wheelbase taken in position, and small d is the horizontal distance between AC and BD. So d is the horizontal distance between AC and BD. So that is the AC and BD. So this is the distance between small d, and small c is the distance between of the pivots A and B of the front axle, and x is the distance moved by AC to AC dash position, that is CC dash, which is also can be taken as DD dash in the other side, and alpha is equal to angle of inclination of the links AC and BD to the vertical. So to the vertical position it is taken as the angle of inclination. And from triangles A dash, C dash, tan alpha plus phi is taken as A dash C dash by A dash, and A dash C dash means A dash means x, so that is taken as the x length, sorry d length, plus C dash is taken as x divided by A dash. A dash means, so this is the length to be taken, A dash. So A dash means small a. So from triangle A dash C, tan alpha is taken as A dash C by A dash, that is D by A. So this is taken as second position, that is the second link. And from the triangle BB dash D dash, tan alpha minus theta is taken as B dash D dash by BB dash. So total it is taken as D minus X by X. So from the 3 points, that is 1 and 2 and 3, we are going to take it as, we know that tan alpha plus phi is equal to tan alpha plus tan phi by 1 minus tan alpha into tan phi. So totally we can take it as d by x, sorry d plus x by a is equal to tan alpha is taken as d by a plus tan alpha, and 1 minus tan alpha is taken as 1 minus d by a into tan phi. So totally after cross checking these values, so d plus a tan phi by a minus d tan phi. So this is the total value obtained from the equations 1 and 2. And tan phi is equal to ax by a square plus d square plus dx. So by substituting the values in the position, we are obtaining this equation, and it is the fourth equation. Similarly, we can also take tan alpha minus theta, that is d by x by a. So d minus x by a, we can get tan theta is equal to ax by a square plus d square minus dx. That is the fifth similar position. So this is the fifth similar angle. And by all considering, we know that for correct steering, we have to take it as C by B. So for the correct steering of the elements, we are going to take it as C by B. Then therefore 2 tan alpha is equal to C by B. 2 tan alpha is equal to C by B, or tan alpha is equal to C by 2B. So tan alpha is equal to C by 2B. 2 tan alpha is equal to C by B. So this is the general position for the Davis steering gear mechanism. But we are using the sliders here, so this is going to be wear out. So that is why Ackermann's steering gear mechanism is widely used. Next, coming to the comparison with the Ackermann's and Davis steering gear mechanism. The whole mechanism of the Ackermann's steering gear mechanism is on the back of the front wheels, that is in the turning pairs only. But coming to the Davis steering gear mechanism, it is in the front of the wheels, and it is of the sliding pair. So that is of the sliding pairs only. So that is why we are using the Ackermann's steering gear than the Davis steering gear mechanism, because of its types of pairs. So for a turning pair, it is not wear out quickly, but in the sliding pair, it is going to be wear easily wear out. And the Ackermann's steering gear mechanism is mostly used because of the true rolling is achieved by the instantaneous center. So because of the rolling of the instantaneous center, the Ackermann's steering gear mechanism is mostly used. And Davis steering gear is theoretically correct than the Ackermann's steering gear, but due to the presence of more sliding members, the wear will be increased, which produces slackness between the sliding surfaces. Thus, it eliminates the original accuracy. Hence, this type of steering gear is not in common use. That is, Davis steering gear is not used in the common use for the addition of these sliding pair mechanisms. So generally, Davis steering gear mechanism is theoretically correct than the Ackermann's steering gear mechanism. Next, coming to the difference between the Ackermann's steering gear and the Davis steering gear mechanism. So, in the Ackermann's steering gear mechanism, the mechanism is in the back of the front wheels, but coming to the Davis steering gear mechanism, the mechanism is in the front of the front wheels. So that is in the front wheels. But coming to the Ackermann's steering gear, it is in the back of the front wheels. So in the earlier slides, you can see that. And in the Ackermann's steering gear mechanism, it consists of turning pairs, so less friction and less wear. So by using the turning pairs, there is not amount of friction in the turning pairs, and that is why it consists of less wearness than the Davis steering gear mechanism. And coming to the Davis steering gear mechanism, it consists of sliding pair, so more friction and wear. So it consists of sliding pair, so that it consists of more friction and more wearness. And next, in the Ackermann's steering gear mechanism, positions of correct gearing are, so positions of this correct gearing are when the vehicle moves straight and the vehicle moves a correct angle to the right and left, and in other positions slippage occurs. So there are three types of positions in the Ackermann's steering gear mechanism. That is to the when automobiles travels to the straight position, and when the automobile moves in a correct angle to the left position, and when the vehicle moves in the right side position. So these are the three types of positions of the Ackermann's steering gear. And in the device steering gear, it is an exact steering gear mechanism and fulfills the fundamental equation of gearing in all the positions. So in all the position of steering, it consists of the correct steering gear mechanism. So this is the basic difference between the Ackermann's steering gear mechanism and the Davis steering gear mechanism. Next, coming to the steering defects and their causes and remedies. First one is the wheel wobble. So first steering defect is the wheel wobble. So in this wheel wobble, the oscillation of the front wheels at low speeds is called the wheel wobble. So the oscillation of the front wheels at very low speeds. So that is chala chinnaga tirige vatni wheel wobbling antarama. And the causes for the wheel wobble. So first one, incorrect dynamic balancing of wheels. So incorrect dynamic balancing of wheels, it is caused, and the remedy is correct the wheel balance. So to balance the right side position of the wheel and the left side position of the wheel. So by correct steer wheel balance, it can be not be caused. And second one, uneven tire pressure. So when the uneven tire pressure is caused, the remedy is to check the tire pressure. So we are going to check the tire pressure first. So what are the pressure occurred on the tire? The next one, third one, the camber may be incorrect or uneven. So the camber may be uneven inside, and it can be adjusted suitably. So it is adjusted suitably position. And next one, the ball joints may be worn out. So when the ball joints is highly used, it is going to be worn out. So that is going to be worn out in position, and it is replaced with a new one. So when it is going to be, so ఎక్కువగా అరిగిపోయినాయి అనుకున్నాం, ఏం చేస్తామంటే దానికి మెయింటెనెన్స్ ఏమి ఉండదు. నెక్స్ట్ ఏం చేస్తామంటే పాత వాటి బదులు కొత్త వాటిని రీప్లేస్ చేస్తాం. సో దట్ ఈస్ ద ఓన్లీ రెమెడీ ఫర్ ఏ worn out ball joints. So atla matrame cheyagalam. Next, excessive caster. So excessive, in place of excessive caster, the remedy is going to be adjust the excessive caster. So adjusting the caster may be the excessive. Next one, steering gear or wheel bearing may be loosened. So when the steer gearing or the wheel bearing may be loose, it is going to be adjusted, or it is highly loosened. So ఎక్కువగా లూజ్ అయిపోతే మాత్రం యూజ్ టు బి రీప్లేస్. సో ఎక్కువగా అరిగిపోతే ఏం చేస్తాం, ఎక్కువ లూజ్ అయిపోయినా కూడా మనకి ఏం చేస్తాం అంటే టైట్ చేయలేం, కాబట్టి దాన్ని రీప్లేస్ చేసేసుకోవాలి. వీల్ బేరింగ్ మొత్తాన్ని కూడా, వీల్ బేరింగ్ కానీ స్టీరింగ్ గేర్ మొత్తాన్ని కూడా రీప్లేస్ చేసేసుకోవాలి. లాస్ట్ వన్, టైర్ మే ఓన్ అన్ఈవెన్లీ. సో టైర్ కూడా ఎలా పడితే అలా అరిగిపోయింది అనుకున్నాం. సో ఎక్కువ కండిషన్స్ లో అట్లా ఏం జరగదు కాబట్టి టైర్ అనేది ఫ్లాట్ గా ఉంటుంది. కానీ ఫ్లాట్ గా లేకుండా అరిగిపోతే మాత్రం it is going to be replaced. So we want to replace the tire. So these are the steering defects. First defect, that is the wobbling of wheel. So condition to be adjusted with the wheel wobble. Next one is the high speed shimmy. So in the high speed shimmy, the oscillation of the front wheels at the high speed is called as high speed shimmy. So the oscillation of the front wheels at high speed is called as high speed shimmy, and it consists of a wheel rim. It may be buckled, that is buckling of the wheel rim, and it can be straightened or replaced. So మనం ఎప్పుడైతే వీల్ రిమ్ అనేది బక్లింగ్ అవుతుందో దాన్ని స్ట్రైటింగ్ గా చేసుకోవచ్చు, లేకపోతే రీప్లేస్ అయినా చేసేసుకోవచ్చు, టోటల్ రీప్లేస్ అయినా చేసేసుకోవచ్చు. నెక్స్ట్, ఫ్రంట్ వీల్ బేరింగ్ మే లూజ్ ఆర్ worn out. సో మళ్ళీ ఫ్రంట్ వీల్ అనేది అరిగిపోతే నెక్స్ట్ ఇట్ మే బి టైటన్ ఆర్ రీప్లేస్. సో అది టైట్ అయినా చేసేసుకోవచ్చు, నెక్స్ట్ రీప్లేస్ అయినా చేసేసుకోవచ్చు. నెక్స్ట్, faulty shock absorber. So first, third one is the faulty shock absorber, and it can be replaced. So faulty shock or absorber కూడా replace చేసేసుకోవచ్చు. Next, incorrect towing. So incorrect towing ని adjustment చేసేసుకోవచ్చు. So we can be adjusted the incorrect towing. So this is for the high speed shimmy. High speed shimmy లో మనం అడ్జస్ట్మెంట్ అనేది చేసేది. నెక్స్ట్ వన్ ఇస్ ది ఎక్సెసివ్ బ్యాక్లాష్ ఇన్ స్టీరింగ్. సో ఎక్సెసివ్ బ్యాక్లాష్ ఇన్ స్టీరింగ్ లో, సో దట్ ఈస్ స్టీరింగ్ గేర్ బేస్ మే బి లూజ్. సో స్టీరింగ్ గేర్ బేస్ అనేది లూజ్ అవ్వచ్చు, దట్ ఈస్ ఆఫ్ ది టైటన్. సో టైటింగ్ చేసేసుకోవచ్చు దాన్ని. అండ్ సెకండ్ వన్, డ్రాప్ ఆర్మ్ మే బి లూజ్ ఆన్ స్ప్లైన్స్. సో డ్రాప్ ఆర్మ్ మే బి లూజ్ ఆన్ స్ప్లైన్స్, that it can be replaced. సో డ్రాప్ ఆర్మ్ అనేది మనం రీప్లేస్ చేసుకోవడమే. సో దాన్ని టైటన్ చేసేసుకోవడానికి ఉండదు కాబట్టి రీప్లేస్ చేసుకోవడమే ఒకటే చేంజ్. నెక్స్ట్, ఫ్రంట్ వీల్ స్టబ్ యాక్సిల్ బేరింగ్ లూజ్ ఆర్ worn out, that is to be tighten or replace. సో ఫ్రంట్ యాక్సిల్ స్టబ్ యాక్సిల్ అంటున్నాం కదమ్మా, ఈ స్టబ్ యాక్సిల్ అనేది అప్పుడు లూజ్ అవుతుంది. సో లూజ్ అవుతున్న తర్వాత లేకపోతే అరిగిపోతుంది. సో ఇట్ ఈస్ టు బి tighten or replace. And next one, loose steering linkages. Loose steering linkages అంటే మనకి కరెక్ట్ గా స్టీరింగ్ అనేది పొజిషన్ లో ఉన్నా కూడా మనకి సో ఎంత తిప్పుతున్నా కూడా వీల్స్ అనేది తొందరగా మూవ్ అవ్వవు. సో అట్లాంటప్పుడు ఈ లూజ్ స్టీరింగ్ లింకేజెస్ అనేవి వస్తుంటాయి. దట్ ఈస్ డ్యూ టు బి టైటన్ ప్రాపర్లీ. సో అట్లాంటి వాటి దగ్గర టైట్ చేసేసేయాలి మనం, టైటన్ ప్రాపర్లీ. So this is for the excessive backlash in the steering. And next one is the steering wander. So what is meant by a steering wander? The moving of vehicle slightly in one side is known as wandering. So vehicle అనేది జస్ట్ ఒక సైడ్ మూవ్ అవుతుంది, అంటే పూర్తిగా ఒక సైడ్ టిల్ట్ అవుతుంది. సో ఆ టైప్ ఆఫ్ మూవ్మెంట్ ని స్టీరింగ్ వాండర్ అంటారు. సో స్టీరింగ్ పొజిషన్ అనేది కరెక్ట్ గా చేసుకోవాలి. సో వాటి కండిషన్స్ ఏంటి చూద్దాం. ఫస్ట్ వన్ ఇస్ ది టైర్ ప్రెషర్ ఇన్ టూ సైడ్స్ ఈజ్ నాట్ ఈక్వల్. సో మనకి రెండు టైర్స్ లో కూడా, లెఫ్ట్ సైడ్ టైర్ రైట్ సైడ్ టైర్ రెండిట్లో కూడా ఎయిర్ అనేది కరెక్ట్ గా లేనప్పుడు, సో అట్లాంటప్పుడు ఏంటంటే మనకి ఈ స్టీరింగ్ వాండర్ అనేది వస్తుంది. సో వీఆర్ గోయింగ్ టు చెక్ అండ్ కరెక్ట్ ఇట్. సో కరెక్ట్ గా బ్యాలెన్స్ చేసుకుంటే సరిపోతుంది దాన్ని. నెక్స్ట్, స్టీరింగ్ నకిల్ బేరింగ్ టైట్. That is steering knuckle bearing tight, that is to be adjusted. So ఆ టైప్ కండిషన్ మనం అడ్జస్ట్మెంట్ సరిపోతుంది. నెక్స్ట్, బ్యాడ్లీ worn టైర్. సో టైర్ పూర్తిగా అరిగిపోయినప్పుడు కూడా, సో ఒక సైడ్ టైర్ అనేది పూర్తిగా అరిగిపోయింది, ఇంకొక సైడ్ బాగానే ఉంటుంది. సో ఆ టైర్ వర్న్ అయినప్పుడు కూడా మనం రీప్లేస్మెంట్ చేసుకోవాలి. సో అట్లాంటప్పుడు కూడా స్టీరింగ్ అనేది కరెక్ట్ గా ఉండదు. నెక్స్ట్, ఇన్కరెక్ట్ టోయింగ్. సో ఇన్కరెక్ట్ టోయిన్ అంటే మనకి కరెక్ట్ గా ఫిట్ అవ్వదు. సో ఇన్కరెక్ట్ టోయిన్ లో కూడా కరెక్ట్ గా ట్రీట్ చేసేసుకోవాలి. దట్ ఈస్ టు బి కరెక్ట్ ఇట్. So for these conditions, backlash, sometimes called as lash or play, is clearance or lost motion in a mechanism caused by gaps between the parts. So between these parts, it is called sometimes lash or play, and this is of the clearance or lost motion in a mechanism caused by the gaps between the parts. So this is the condition. అండ్ ఇంకో కండిషన్ కూడా ఉందమ్మా మనకి, హార్డ్ స్టీరింగ్ అనే కండిషన్ కూడా ఉంది. సో హార్డ్ స్టీరింగ్ అంటే when the effort required for steering is more, it is called హార్డ్ స్టీరింగ్. సో ఎక్కువ ప్రెషర్ కానీ ఎక్కువ పెడుతుంటే మనకి, సో పవర్ స్టీరింగ్ లో అంత ఎఫర్ట్ అనేది పెట్టాల్సిన అవసరం ఉండదు. సో పవర్ స్టీరింగ్ కానీ మొత్తం కూడా మనకి హార్డ్ స్టీరింగ్ కిందకి వస్తాయి. దాంట్లో ఫస్ట్ వన్ వచ్చేసరికి లో టైర్ ప్రెషర్. సో ప్రెషర్ అనేది తక్కువగా ఉండటం వల్ల మనకి, సో టైర్ లో ఎయిర్ బ్యాలెన్స్ ఇవన్నీ తక్కువగా ఉన్నప్పుడు ప్రెషర్ అనేది కరెక్ట్ గా ఫిట్ చేసుకోవాలి. సో మన టైర్ పొజిషన్ అనేది 40 ఉన్నప్పుడు మనం 35 పెడితే కరెక్ట్ గా 30లో ఉంది, కరెక్ట్ గా 40 పెట్టేసుకోవాలి. నెక్స్ట్ ఎక్సెసివ్ క్యాస్టర్. సో ఇట్ ఈస్ టు బి అడ్జస్టెడ్ when it has excessive caster. And steering gear too tight. So when the steering gear is too tight, it is going to be adjusted. సో స్టీరింగ్ గేర్ అనేది ఎక్కువగా టైట్ చేసినా కూడా మనకి పొజిషన్ లోకి రాదు. సో అట్లాంటప్పుడు అది కూడా అడ్జస్ట్ చేసుకోవాలి. నెక్స్ట్ ఇన్కరెక్ట్ వీల్ అలైన్మెంట్. సో వీల్ అలైన్మెంట్ కూడా కరెక్ట్ గా పెట్టేసుకోవాలి. దట్ ఈస్ ఇన్కరెక్ట్ వీల్ అలైన్మెంట్. సో అలైన్మెంట్ అనేది అప్పుడప్పుడు రెగ్యులర్ గా చెక్ చేసుకుంటూ చేస్తూ ఉండాలి. So that is of incorrect wheel alignment. It is also to be adjusted. So that is to be adjusted. So these are the basic conditions and applications of the steering gear mechanism and Ackermann's and Davis steering gear mechanism. Thank you.